Hi folks, my name is Sam, and today we'll be demonstrating how you can use RelationalAI's integration with Snowflake's Snowpark container services to solve a real-world problem, namely telecommunications fraud. Fraud is a major concern for service providers because it affects customers' day-to-day lives in all sorts of ways, with spam texts increasing by 700% last year alone. It's also very costly for providers as losses from fraud total over $40 billion a year globally. Machine learning methods can go a long way toward helping providers identify fraudulent activity, and machine learning is even more powerful when organizations are able to leverage a knowledge graph with graph analytics capabilities like the ones provided by RelationalAI. Let's jump into it. First, you'll want to enable the RelationalAI integration in Snowflake. With Snowpark container services, you'll be able to do that with a command like create service RelationalAI. We'll be working with real data that was released by a large telecom provider in 2020. It contains a table of featured user IDs along with a flag indicating whether each featured user has been involved in fraudulent activities. It also includes tables showing the users that were involved in the voice calls and text messages that each of those featured users sent or received over a 6-month period. This kind of data is a natural fit for Snowflake given the scale of the data and the importance of the problem. Notice that the only user attribute provided by the dataset is the variable we're trying to predict, the fraud indicator. This means that all of the predictive features you'll use in your machine learning model will have to be obtained as aggregations over the call and text tables. For example, you can ask for a user's number of outgoing calls, the number of people who are a contact of a given user, in other words, a second-degree contact, and so on. These quantities are easier to think about if we draw a picture that highlights the graph structure of the data. You can show the network users as nodes and the calls and texts as links between them, and this perspective opens up the whole world of graph analytics for your machine learning problem. Some simple graph features are quite manageable to calculate directly in SQL. In this worksheet, you have a long SQL query that computes several quantities, including incoming and outgoing call and text counts and the number of callbacks and textbacks. Let's investigate how well an XGBoost model can predict the fraud variable using these features as input variables. This is a typical training routine. It begins with a train test split and then performs a grid search to find the parameters that achieve the best fit. The test precision and recall of the resulting model are 85% and 78% respectively. That's a good start, but if you want to take your model to the next level, you'll need to be able to leverage more advanced graph analytics capabilities than what you get by writing your own SQL code. Doing that with RelationalAI allows you to do your graph computation without giving up the benefits of Snowflake, like scalability, security, governance, and a familiar experience for SQL users. To do that, start by creating a Snowflake view that includes the columns you're actually using in your graph. Then project that view with a RelationalAI database using RAI.createDataStream. Lastly, specify the columns you want to use to create a RAI graph. Once those steps are done, you can use functions like RAI.triangleCount, RAI.pageRank, or RAI.eigenvector centrality on your graph. You can specify a node argument to tell these functions where to place the results of their computations in the Snowflake table. Lastly, we'll want to join these tables so we can use them to augment the features we already calculated in SQL. Back in our Python worksheet, we can turn the include graph features flag to true and retrain. We find that the precision and recall improve by about 3% and 1% respectively. We can visualize how the graph analytics features help the model identify fraud by looking at an illustration that shows both PageRank scores and fraud. Node size is proportional to PageRank score in this picture, and the fraud nodes are orange. You can see how the PageRank scores help separate the fraud and non-fraud nodes. This improvement, which corresponds to a loss reduction of $1.6 billion industry-wide, shows the power of integrating Snowflake and RelationalAI when dealing with graph-structured data. And this is really just a starting point. Between RelationalAI, Snowflake, and Python, you have all the tools you need to investigate model improvements using any graph analytics quantities that might be useful. And that's it for today's demo. We're excited to be building this together with the engineers at Snowflake. If you'd like to give the preview a try, click on the link in the description. See you!